Okay, so I wanted to touch on the reference architecture that NVIDIA published not too long ago called NVQLink. So this is an interconnect technology that facilitates interconnectivity between QPUs and GPUs and the rest of the existing supercomputing and HPC stack. So it's really putting forth a reference architecture for the industry to put a stake in the ground, essentially, of what is the role of GPUs in this quantum data center. GPUs can be used for a variety of things. You can see the role of GPUs perhaps being more clear here as carrying out the quantum error correcting codes and the decoding operations, but also really driving the system controllers, those QPU controllers and pulse drivers that I mentioned earlier. What's really interesting is that in the NVQLink reference architecture, they broke down different time regimes and considered one regime where the GPU is tightly coupled to the rest of the logical QPU, so the system controller and the physical QPU itself. So in this tightly coupled regime, we have real-time interconnects. So this is often RDMA over Ethernet or other kinds of interconnect technologies. It's purely classical link here, but it needs to be, again, very low latency to communicate with the rest of the control stack. So GPUs in that tightly coupled regime are really useful for driving the error correction feedback loop, but also doing the logical orchestration of the physical QPU itself. And then they consider the other regime, which is the loosely coupled regime, where now we get more into the applications side of things and the algorithm side of things, where GPUs can interact with this whole logical QPU abstraction, which opens the doors for some really interesting research and possibilities into how can GPUs and a logical QPU, or potentially a network of logical QPUs, work together. And they're very different computational platforms, but then we can get into the HPC applications of this future quantum data center. One area that's getting a lot of attention is these variational algorithms, where you're carrying out certain quantum workloads on the QPUs. You're reading out those results, doing some kind of optimization or feedback loop with the GPUs to drive the next iteration of that circuit and adjust those parameters as you go. So I thought it was a really interesting kind of breakdown of the different problems in latency and the constraints that this NVQLink architecture needs to meet, both in the tightly coupled regime to really sit close to the QPU itself, but also in this loosely coupled regime. So they've really considered this architecture kind of narrowing down on a single logical QPU platform, which is not an easy problem at all, and it's a great problem to tackle. And I think another nice thing is that they've been able to get this reference architecture widely adopted in industry already. So all these different quantum computing companies and approaches are beginning to adopt and partner with NVIDIA to embrace this reference architecture, which for the whole ecosystem, I think is a really healthy and critical thing. When you talk about a quantum data center, it's a network of these logical QPUs. There's not going to be one monolithic logical QPU. It's going to be a network of these logical QPUs. So how can we extend on this reference architecture to consider a more complex network? And that's something we're really interested in thinking about.